Hi team. I was looking through your progress reports and I was a little concerned that it looks like you guys can't test your camera until you get your Python stuff going, and I'm worried that might send you behind a little bit. It's going to take a while to figure that out. I think you need to figure out whether your camera's going to work or get something else. So I want you to start testing your camera right away. So what I did is I've uploaded a file here that you can run right now on your Pico, start taking pictures and seeing what's going to work, testing out different lenses. I'm going to go ahead and demonstrate it for you here really quick so you can see how to use it, but you can just throw it on there and do it. So what I'm going to do is I'm going to go ahead and I'm going to plug in the Pico. So if I just show you here, I've got the Pico set over here. Hopefully my camera can see it. I got the SD card. We're not going to use that. So I've just got the camera set in with those default SPI pins that were in that. So I'm going to go ahead and just plug it in. And then I'm going to go ahead and open up Thani. So you see it over here, and so on COM7, and so it's actually I'm actually working on that Pico. And then I've opened the file on the top here. This is the file I gave you, capture.py, and this is what it is here. I'll explain that here, but right now you could just do this, and then you can go ahead and click run. So I'm going to go ahead and click run, and you're going to see some diagnostic information. I'll explain that. It's testing the camera, and then it's writing a bunch of the data, and then it's done. So at this point, you can go ahead and just unplug the Pico. I'm going to plug it back in just so it rereads the file system. And so if I do that, and then I'm going to go ahead and go down to the circuit Python, you'll see that there's that myfile.jpg. If you open that up, there's a picture. That's me. I just had it sitting here on my desk, so you see a picture of it. It took there. So again, open this file. I'll open this file in Thani, plug in your Pico, click run, and you can start getting pictures, and then you can start testing out stuff. So what I'm going to do with the rest of this video, though, is I'm going to explain just briefly that file I'm giving you, capture.py. So that if you want to know more what I did, because you might want to kind of modify this as well. So first of all, this capture.py, let me mention what that is. There's that SPI cam documentation on GitHub. And there's actually another, I think I gave you the link for that, an arducam, this OV2640 Pico package function that actually used it. So if you see it uses the Pico SPI cam folder, and then in here in this Pico file, inside code, I think it has this thing called Pico Imager, and this is actually what I hacked. So you'll see mine is essentially this one over here, but this is what I hacked, and so I called mine capture.py. That's what I have. So put on the SPI cam stuff. What this is a modification of that streaming Python thing, and what it normally did was it would just stream your pictures from your camera onto the computer that you had if you're plugged in. What I do is instead of streaming it to the camera or streaming it to your computer, I'm writing just a single picture onto the Pico, and you're done. So you see there's this import stuff. I have some importing stuff for SD card. We're not going to use that right now. I wouldn't you'll eventually want the SD card probably or USB storage, but don't worry about that for now. But you can leave it in, it's fine. There you see it imports the arducam. This commented stuff, these are these codes, and every time you want to use one of these codes, it'll do a thing. And so for example, we're going to send code 10 because that's going to capture an image. Instead of sending it to UART, which is a serial port, it's actually going to write it to the Pico. I'll show you that. That's the hack that I did. Here's some numbers, just sets up. There's some internal stuff. You'll see I commented out the UART because we're not going to use the serial port. What you're actually going to do is you're going to save it to a file, and you can either use an SD card. I have it set to false because I didn't write it to the SD card, so it doesn't do these things here. It just does the else statement, which creates a binary file called myfile.jpg. That's the one I showed you, and it's writable, and it's a binary file, so it doesn't do this stuff. I can explain the SD card stuff if you want, but how that works. So then it sets up the arducam. So this was, if you look at the bottom over here when it said camera types OV20, that's it set up an instance of the arducam class. It detected it. It did an SPI test. So it says SPI interface okay. It initiated it to a JPEG file. So you see I commented that other file type, and then it saved for a second. I'll explain the FIFO stuff here in a minute. So there's a function to find FIFO. We'll come back to that. It doesn't run next. It's just a function. And then when it comes down over here, the rest of this was just this one big infinite loop that would wait for the user to type something on their computer, and then it would run that various option. I changed that to where it just does this loop once, and I send it a code, that code 10, for example. So I've commented out the infinite loop, the while true, that was an infinite loop, and I defined it into a function called doStep, that was my function name, send it a value, which we're going to send it 10. And then what it does is it does one of these if-else things. And so it's going to come down over here and it's going to do 10. And 10 actually starts the capture. So it takes the picture. And so there's all these various codes you can send it. I'll explain those a little bit more in a minute. But and so if you come down at the end, that's the end of the function. So the last thing that the program does, do step, and I send it code 10. So it's going to go and do that function, do step. It's going to do it with code 10, which takes a picture. And then it's done. And then it's actually I already closed the binary file, so it's going to go ahead and be done. That was what we ran. So when it runs it, that's what it does. These various codes, we mentioned that over here. So I just take the picture, but you could go ahead and do various things and then take the picture. So if maybe you want to change the JPEG size larger, the largest size is 16 by 200. That's code 8. So what you would do, if you wanted to hack this further, is you would just say do step, and you would send it 8. So it's going to do that loop once. It's going to send it 8. It's going to change the file size to the JPEG size, and then it's going to go ahead and the 10 is going to take the picture. Maybe you want to make it larger, and then you want to set the, there's all these various contrast settings and stuff, so maybe you want to go ahead and change it to this contrast 2. These are the things you can test out. Contrast 2 is 70, right? So then you would a do step, 0 by 70, and so it's going to change the file size, picture size. It's going to go ahead and change the contrast, and then it takes the picture. So anyway, you can go ahead and hack that. That's the stuff you guys can go ahead and test out. But in the short run, all you do is plug in your Pico, open my capture file, hit plug, and you're going to have a file in there called myfile.jpg with a picture on it. Let me mention one other thing. Jenny mentioned that you guys weren't able to copy files directly on there, and that's because the Picos by default are read-only. But I can show you a quick workaround from that to fix that. In fact, you'll need to do that if you want to go ahead and be able to write that JPEG file. So I need to plug this in again. I'm going to plug in that Pico again so I can show you something else that's another file I have on there. So I'm just plugging my Pico back in. You see it down there, circuit pi, it's a drive 5. So you'll see in mine, I've got this boot.py file as well. So if I open this up, it's a real simple file. It just says import storage, storage.remount that. Add this file to your Pico, call it boot.py, and stick it in there. So you'll if I come back over here, you see there's my there's OV reg files. Those are the ones you copied in, and the arducam.py we're actually not using, but the arducam OV2640, that's that import file that it did. So those are the 3 files that you needed. Boot.py runs at boot up, and what it does is it sets it to not be read-only file system. So you'll go ahead and just want that. So put that file on your Pico first, run capture. You'll then start having these files called my file.jpg, and then you can just rerun it every time and take a picture. It'll overwrite that my file.jpg file, and I think that should get you going. I'm not going to make this any longer than it needs to be. If you have any questions about any of this stuff, help me out. If you're curious about this SD card stuff, what I did is, this is where I'm setting up the SD card on those I'm using the other SPI clock, and then I made it so that the file name wasn't always my file.jpg because I was taking lots of pictures. So I create a real-time clock, and then I make it like hour, minute, day.jpg. But anyway, that doesn't get used right now, and if you're interested in it, I can explain that more. Anyway, this will get you up and going, hopefully. So if you have questions, you want to come and talk to me about it, happy. But hopefully the video lets you kind of take some time, and you could rewind and watch it and look at what I have in here. And if you have any questions, please let me know.